Okay, guys, so welcome back to my YouTube channel. This is going to be the second video, of course, and based on the feedbacks I've received from the first video, I'm going to change my method of presenting, of course. So you can see now I'm doing it live here right in front of the board, and it definitely looks more clear than the first video. So uh, continue showing your support and share this video around to help students that might just be taking AdMaths now in Form 4 or those who already started their Form 5. So let's get started with it. So what we are going to do today is composite functions. Okay, so I don't want to go directly into the topic of composite functions, but let's talk a bit about what's the meaning of composite first. So to understand this word, I actually came up with two examples. One is talking about composite index in Form 4, and another one is about composite materials, which you learned in your chemistry Form 4, Chapter 8. So those who just start Form 4 now, you might not know this, but those who are just starting Form 5, these are the two last chapters in both NMATS and chemistry of Form 4. So I hope this video will be useful. So let's see. Okay, first of all, so composite functions. So first of all, composite functions are a combination of more than one type of function. So this is the key thing, more than one type. So if you have only one function, based on the previous video we have learned, let's say I give you fx equals 2x minus 4. So that is not called the composite function because that's only one type of function, one alphabet. So if you're talking about composite, it's going to be a complex function. Means the result that you get from a composite function won't be such a simple equation, and it might have variables like x power 2, x power 3, because we are substituting an equation into another equation. So when you expand, you most likely will get a variable that's more complex or maybe an higher number. Let's say 2x minus 4. Maybe you'll come to something like 6x minus 28, let's say. So the result of composite function should be definitely larger than the two functions given on top. So that's a general idea. And now I'm going to link it to one of the chapters in Form 4, which is composite index. The whole chapter is price index. This is one part of it. So I put this formula here. So why I put this formula is you can see composite index of A based on B. So these two are actually talking about the years. A is representing a year and B is another year, but A must be a later year than B. So this is the condition. A must be greater than B. And then this is the formula, sum of index times weightage over weightage. So what I'm emphasizing here is the word composite. So how we know it's composite is because of this thing here, the sum sign. Because sum means you're going to combine the product of index and weightages of different items. So that's what causes the resultant composite index here to be something like an average of everything. So this is what we actually kind of doing like in composite functions. So that's an idea. So it's combining more than one price index of an item to find resultant index of a year based on another year. Okay, so that's I think quite clear on the starting part of composite index. And now we shall look here about the chemistry part, which I thought of. So how to understand the word composite? So you should think of composite materials. This one you have learned, I think almost the last part of Form 4 chapter 8, if I'm not mistaken. So what is actually composite material? So it's actually combination of two or more. So you see this thing repeating again. Here also it's a combined more than one price. So it has to involve more than one. Here is two or more. In this case, non-homogeneous substances means not same. Homogeneous means same. So non-homogeneous will cause it to come not same. So these two substances can be the matrix and strengthening substance. So I'm just elaborating more what I mean by this two or more non-homogeneous substance. So the examples you can see here. First one is reinforced concrete. So I'm just giving you an example of what I'm talking about. Matrix and strengthening substance. So you can see matrix substance is concrete because the word here itself contains concrete. Right? So then strengthening is steel bars and rods. So this one is mainly used to build bridges, reinforced concrete. And then another one is photochromic glass. So matrix substance, of course, glass at the back. And then strengthening, silver chloride, copper 1 chloride. So these are just examples. So I'm not going deeper because I'm not teaching now chemistry, but at math. So I'm just giving you an idea how actually these composite functions, they actually, what's the thing involved in doing it. Okay. So yeah, this is the first part. So now we going to the real deal of composite functions. Okay, let's see. Okay, so first of all, in composite functions, you're going to see two main things that form the composite function, which usually they will tell you is fx and gx. But it can be anything. Usually it's this. So most of the questions will give you fx is what and gx is what, and then ask you to find the composite function. So composite function can appear either fgx is the first chance, or the second chance it can also be gfx. So we have two chances here. Since we have two functions, right? So we can combine these functions to form two combination of composite functions. Okay, so that's one thing. And most cases, this is some info about these functions. Most cases, your fgx will not be equivalent to gfx. Most cases, but sometimes they'll ask you like a question proof that fgx equals gfx based on the functions they give. So you have to do two separate scenarios here. So you have to do fgx, and then you do until down here, and then gfx, you continue doing until down here, and you find out the result here and the result here. So if you want to prove it, you must make sure the value of your left-hand side is equal to your right-hand side. This is the main concept behind proving. So sometimes it can be equal, so it depends on how the function, the separate functions are structured on top here. So there is a coincidence where they can also have an equivalent value, although we are doing it in a different order, but that's the minority. So these are some briefings about composite functions that you can expect later on. So now we will properly do how to do composite functions. Okay, so first of all, you need to know what is happening behind why they call these terms as gfx and fgx. So everything has a reason, right? So why they label it like this? So how to read this kind of labeling? So you must know how to read. So gfx is basically you're going to sub the f function to g. This is the order. Means f function will go first, g function will go second. That's why it's gfx. And then you read from right to left like this. And then if fgx means we are sub g function to f. So in this case, g will be your first function, f will be your second function. And one way to prove why it comes like this is separate section. It's not related to NMATs, but in mind, we call your combined transformations how you do. Let's say I give you T is a reflection in the line x equals to, and let's say U, let's say I put enlargement, positive enlargement with a scale factor of 2 at about center of enlargement, just a random coordinate, I will give negative 1, 0, let's say. So how we are going to do this transformation on a Cartesian plane is, let's say they ask you number 1, find the coordinates of the image under this transformation TU. This is what we're actually doing here in your composite function. When you combine these two things, you're going to get an image because it will be in the form of g f x. X is your object, but this whole function g f x is where your object maps to each image. So this is the concept behind it. So how we do combined transformation is, if it's TU, you're going to do your number U first, then only you proceed to the T. So this is the same thing. You do your F first, then you go to your G. So this is an easy way to remember how to do composite functions exercises. So if they reverse, same also. Let's say I ask to do UT, means you're going to do T first, and then you proceed to U. And you will get your coordinates of the image. So this is what we are doing here, exactly same thing. So I think this is clear a bit. So it's a good example for you to keep in mind this. So let's proceed. Okay, so the key thing to note in composite functions, so FGX. So now this is the proper how you want to read this function, not just as what I say now, FGX, in the proper way to write it out. So FGX actually means F compose with G of X. So it actually follows the order of the function. You can see FGX, F compose, composite function. That's why they say compose with G of X. So it follows exactly. So F and G represents the function of this particular object which has a variable X. Later we can substitute random values to find the correlation between object and image. But just as a general formula, we will put as X in anything. So this is something like your nth term that you learn. We don't know what is it, but we can put random values to find the value of the whole expression. So if it's GFX, it's the same thing. G composed with F of X. So it's another way to remember which one to do first. So you have to do your F of X first, then only compose with your G. Don't follow it as the reading from left to right. You have to go to the balik. So what is actually happening here, when you write FGX, it actually means like this. F bracket gx means your gx is in a bracket, and whenever something is in a bracket, right, you'll always recall one thing: whatever in the bracket, we have to solve first using this technique, BODMAS, and it's a famous one. So that's why we are going to do this function first, then only proceed to F. This is another way to prove what I'm saying. So that's why we put this bracket here. So when you have the gx function, this is going to come, let's say the gx function is 2x minus 4. So you see this 2x minus 4 is actually your x under the function of fx. So this and this is the same. X is 2x minus 4. So we're going to substitute this x value into the fx function that's given to find your fgx. So this is the principle behind it. If you want to see the other side of it, let's say reverse thinking, we do gfx now. So gfx. So gfx will look like this, g bracket fx. So fx is going to be solved first based on this BODMAS thing. And let's say I put fx as 3x minus 5. So for this, 3x minus 5 is your object when we are going to go under the function of gx. So gx in the end will come to gfx because we are substituting the f function inside here. So this is the thing that's going on here. To get gfx, you need the function f to be substituted inside this gx function. So that's how we get the composite function of gfx. So basically, this is your object. The value you find at the end is going to be your image. Okay, so that's about it for this. And then now we are going to practice with variables. So first of all, we need to recall what I told in the previous recording, which was on the introduction part to functions. So that one will help a lot, especially the arrow diagram thing. So that can make you understand composite functions also, because I can put numbers there. So let's say I give like this. Let's say 1, 2, and 3. So let's say random example I put here. So this is going to be your x. This is y, this is z. I put 3 random letters here to represent the function. So let's say I put 2 numbers here. We have to have at least 2 numbers, then only we can derive the general term. Because if one number, it doesn't show you a pattern, one map to here, that's just one-off thing. So to continue the pattern, we have to put a second number here. So let's say I have 1 and 2. So if I assume y is going to be x cubed, means this is the object, this is your image, and let's say I put this under function f. Let's say. So based on this, I put down here a bit. So x cubed. So 1 cube, you'll get 1 also, but 2 cube, you're going to get 8. So you can see the relationship that's going on here. That's why y is equal to x cubed actually. So that's the function that's going on here. In other words, I can put here y equals x cubed, or I can say fx is x cubed, because function f maps the object, which is x, to an image of x cubed. When you substitute the value of x, you can get the value of the fx or the image. So let's say I put an arrow like this, because these two will map to each other. And then to z, let's say z, I say is y plus 8. So the value of y here, you plus 8. Or I can also say x cubed plus 8. Why I say this? Because y is actually x cubed, based on what I told you, this part here. So this is where we combine two things already to form a longer expression. So you'll finally get here from 1. Let's say we go for 1. 1 plus 8, we are going to get 9 here. And 8 plus 8, we get 16 here. So this is going to map to this. And this is going to map to this. So this is the relation that we can form here. So relation can be addition, subtraction, multiplication, and division. We can play with these 4 things, 4 basic operations to form a general formula like this, x cubed plus 8. So if I want to write it out in a sequence, let's say, so let's say I do for this part first, focus your eyes here, only on this top part here. So let's say I want to write out how does it look in a arrow form. So I'm going to start with 1. And then here, this arrow here is actually function f based on here. I assume that as function f. So from here, your image is 1 cube, which is your x cube. X is 1, so you're going to get 1 here. 1 cube is still 1. And then from here, let's say here I'm going to put it as function g. So from here, I have to put g here. So you can see composite happening here because there's two functions. First function f, second function g. So after you do g, you have to take this value. This will come your object now. First, this was object, this is image. But when you repeat with a second function, this will come your object, this is your image. So there's an overlap happening in the middle here because we are combining two functions. So 1 plus 8, you get 9. So this is under function g. So we can actually express it in a general way. Let's say I put here as x. I'm using back the variables on top here. X cubed, which is your y, is going to x cubed plus 8, which is also y plus 8, because your x cubed is y. Same values based on this. So here is going to be your f, here is going to be your g. So I can say that g of x is equals to x cubed plus 8, because this function is going to happen first. That's why I put it at the most right. This function is happening next. That's why I put it at the left. And this is the result you get in terms of x. Because the function, you have to remember, your object is x. So you cannot put y plus 8, although it means the same thing. But since you already fix here as x, you can also put as gfy. Let's say I put gfy, you will get y plus 8. You won't write x cubed plus 8, because the bracket inside here, the object is y. But generally, we will use x to make things simple. Y looks like an image, like on a graph. We won't put, like what I'm saying is, we won't write y and x here. It sounds so awkward, not common sense. So usually graph is like this, y and x. So we are using x here most of the time. So yeah, that's the thing. So another function to demonstrate, we can use the number 2 here. So we focus on this part. So number 2 will go under function f. So it's x cubed, right? The relationship here. So it's 2 cubed, which you will get 8. Means your y value is 8. And then you're going to go under function g to get your x cubed plus 8, which will be 2 cubed plus 8, which is 16. Or you can say y plus 8 also. Y matches with 8 here. So you will get 8 plus 8, which is 16. Same thing, you should get the same answer no matter what. So this is how I prove that y is x cubed on top here by finding your, let's say, like I'll call a secondary image. When you do transformations, you will have object, primary image, secondary image. So gfx and fgx is like your secondary image. This is your object. First function, when you map, you get the image that's primary, first image. But the composite index is your secondary image. So yeah, that's the thing. So now we are going to the arrow diagram. So this part's the one that mostly they will show in exams, I feel. So it's just to understand it. So most common exam questions will show the circle thing. That's your arrow diagram. Okay. So this I call mapping between circles. So I'm using the previous example just now. Remember, your gfx is x cubed plus 8. I'm basing on that to do the relationship here. So first I'm going to go with gfx first. One is by using specific numbers, and another one is by using general, is the general expression form. So if you want to go specific, means I have to put specific numbers inside it. So let's say I have 3 circles here. Just now I use x, y, z also. So I'll put it as x, y, z also here. The same thing. So let's say inside here I have a small x. So this x and x is different, no? This one is big X, the one I write here is small x. So it's like this. So when I map from here to here under function f, same thing like just now. So you will expect to get y equals x cubed. So on top here I can say that fx is x cubed as well. And then here I write z. So I'll put z here as well, small z. So z is y based on the relationship just now plus 8, which is also equivalent to x cubed plus 8. So from here to here, I can say that under function g, gx is x plus 8. So this is the thing happening here, basically. Yeah. So that's the relation between these 3 functions. So let's say I want to put it in a general formula here. 1, 2, and 3. Okay, same thing. X, Y, Z. So again, I'm going to use X here, but the difference comes here. Instead of writing X cubed, the relationship I made on top here, I'm going to use this instead. Y equals fx. Because fx is also x cubed, so I can write as this as well in terms of a general formula. This is under function f, and this one is under function g. And I'm going to get z, I'll use the small z again, is gy, because I'm mapping the object of y to form the image of z. So gy is actually your gfx. So this is the general thing that comes out. And why I say this, how I suddenly I substitute y with fx. This is the proof here. Because I already made the relationship from the primary image that y equals to fx. So I can substitute the value of y with fx here. So this forms my composite function, which equals to gfx. And it makes perfect sense. Because we are doing this one first, this function first, proceed with g function. So you see, first function f, second function g. So that's why it comes out with the expression of gfx. And in conclusion, these two, gfx will map to x cubed plus 8. So this is your, how to write this is called function notation. Usually they give this in the question. When you want to write your answer, you write it like this, in the form of an equation. There's a difference here. I don't have the colon here and this arrow here. I substitute it with a bracket and an equal sign. So that's the difference here. Same meaning, but different way of writing only. Okay, so that's another part. And then now we are going to go to another way of proving this thing. Okay, so let's see this part. Okay, so just now I assume that fx is x cubed and gx x or y. Like just now I say gy because I got y equals fx. So let's say I put gx here. Gx is x plus 8 based on the relationship just now. So if I want to find g of x, I'm going to do g bracket fx based on the order of the substitution. So you will get g. What is your fx here? Based on the question. So you can see that fx is x cubed. So you're going to put this x cubed inside here. And this is when the magic happens. So you see gx cubed. X cubed is going to be your x. So I'm going to substitute this x cubed into the x here. So you're going to get x cubed plus 8. And that was the answer just now. So you see it's proven. G of x is x cubed plus 8. Based on the normal method we use to solve questions. So this is the thing here, x cubed plus 8. So very short way because it's a simple equation only. So yeah, so this one part of it. So that's basically halfway through the composite functions involving different types of functions. But also don't forget, composite doesn't mean I have to refer to different type of functions. It can also mean the same type of functions, which means I'm talking about the same letter. So example, let's say f and f or g and g. Here you see I did f and g together, but here I'm comparing with just one function. I'm doubling up the same function. So how we're going to do this one is actually same concept as this, but just it might look more confusing because it's the same thing repeating. So f square x and also g square x is also known as composite function. Because you see f square x is equal to f bracket fx. This is how we come out with the function, just like how we did just now on the fgx and gfx thing. So let's say I want to put fx is 8x minus 9. How we're going to find f square x? Now we're going to do the composite functions. Something like this, same concept. So we're going to substitute fx inside here. Usually this part is where a lot of people get confused when they start to learn composite functions. To proceed with the second step, to substitute inside, because you see it's like the same thing and you're substituting the same function into the same function. So how we're going to do it is this 8x minus 9 is your x value. So here you have an x value, right? So what you're going to do is your normal substitution in maths. You're going to take this whole content inside the bracket here and put it inside this x. Minus 9, don't forget the back part. Of course, we already wrote minus 9 here. Don't think it has covered for the minus 9 at the back here, not yet. So you have to put a minus 9 also. So from here onwards, basic algebra. Expand here, expand here. So you'll get 64x minus 72 minus 9. So you will get 64x minus 81. So what does this represent? 64x minus 81. So what is the thing on the left hand side? So it's actually f square x, because we doubled the f function. Double the f function. So this is what we are doing here. And g square x will also have the same meaning. G square x is ggx. So this is how we write it. And yeah, this is the thing basically. So just don't get confused with this part only. From this step to proceed to this step, where to substitute, and don't forget your back number also here. And yeah. So if you have troubles finding this, let's say I give you an equation y equals 2x minus 3. and I ask you to substitute x is 8 minus y. So how we're going to do this? This is something like this only. So I'm going to copy back y equals to your x here. They already gave you x here, given x equals 8 minus y. So this is what you're doing here. You put in 8 minus y minus 3. And then you expand 16 minus 2y minus 3. You get 13 minus 2y. So if you get confused at this part to this part, just try with a random equation like this linear equation and put an assumption for your x value in the form of a variable. Because you got to realize here we are substituting variable. So if you put a number, it may seem different to your perception. So that's why I put a minus y so that it looks similar to this. So you see, you will get also an answer in terms of y. And here you see, you get in terms of x as well. So yeah, this is how you do it if you want to understand it better. So yeah, this is the part. And now I'm going to link this to a chapter in NMATS as well, which actually came from your modern maths, quadratic functions. But we have this in the next chapter, which I might do videos also. So the modern maths quadratic function is the basic one. NMATS will add on two methods, that is completing the square and using the quadratic formula. So that's the two extras of NMATS. The simple method here we are using here is factorization. And believe it or not, this method is the key thing that supports many concepts in maths actually. I can give you a few chapters from here itself. Functions. Of course, you're going to use it in quadratic functions. You can use it in system of equations. You can use it in indices, surds, and logs. You can use it in progressions. And it goes on up till form 5. So you can see why this knowledge here of factorization that you learn in your modern maths is so important. Because it can support all the chapters in maths, because you're going to have two x values, x1 and x2. So yeah, this is the thing here. So that's why we involve factorization, even though before the quadratic function chapter in maths in functions, because we already learned it in modern maths from 4 chapter 1. So that's why they already bring it to your form 4 chapter 1 of maths. So it's like simultaneously you do it. So let's try out an example. Most things when you come to the final answer will require you to factorize. It's just what method you're going to use or what method is capable to solve the question at that point in time. So I'm going to use quadratic knowledge. Example. So let's say these are all examples of functions. I give you fx is 2x minus 5, gx is x squared minus 6. So from here, let's say they throw a question here. Let's say they ask you find the value of x if f equals g. So they put a condition here, if f equals g. So what they're actually meaning is your function fx is equal to your function gx, which already provided the info here. So it may look simple, but you still need to know your quadratic knowledge, your factorization. So I'm going to let fx equals gx. So these kind of things that you write on your exam paper is good also, because it gives the hint to the examiner that you understand where you're going from this question here. So you don't just start like 2x minus 5 equals x squared minus 6. Why you do this? You must ask the question back. Why you say like this with this sign? I can put greater than, small than, anything, right? So it's because of this info here. So that's why I proceed. So you want to make it into your general form, right, from here. So we call general form ax squared plus bx plus c. So you're going to arrange this equation into this form. And most likely, most preferably, keep your a value greater than 0. So I won't shift the x squared here because it will come negative when I shift it to the left hand side. So instead, I'll throw all this to the right hand side, all these terms. So you're going to get x squared minus 6 minus 2x plus 5 equals 0. From there, you proceed x squared minus 2x minus 1 is 0. So from here, so this is when you're going to use your factorization. Usually they won't burden you with the formula now because this hasn't reached the quadratic chapter yet. So most likely examples here will just test you on your normal factorization, the one you use your bracket one. So from here, you can actually try with your calculator as well, or you can just like test it out, which one can give you the correct equation. So let's say I test out here, this one, yeah. So it will be something like this, but the top part here, this one here is minus 1. So this one you need to use your quadratic formula, no choice. You can't use the factorization method. Yeah, you have to use quadratic formula. So this one I can't show you here. So it's a good chance to show quadratic formula here as well. So A is 1, B is negative 2, C is negative 1. So from here, you try to write down the formula, although it's given. So your formula goes like this. Remember this part, negative B, not just B, makes a difference. Plus minus square root B square minus 4AC over 2A. So from here, you can sub all the values. X is negative 2 plus minus square root negative 2 square minus 4, 1, negative 1. Be careful of the negative and positive thing. 2, 1. So from here, I'm going to split to get 2x values. So I can go from here and here. So x1 can equal to 2 plus square root. I take the plus first. So 4 minus negative 4. So you will get 8, square root 8 over 2. Or your x2 will equal to 2 minus square root 8 over 2. And this third 8 can be actually simplified. This one comes from your chapter 4 knowledge. So I want to show it here. You'll get x1 is 2 plus 4 third 2 over 2. So you will get 2 plus 2 third 2 over 2. And here you can factorize. You get 1 plus third 2. So that is your x value number 1. So same for the second one, I want to show it's the same concept. So yeah, this is your simplest form that you can have if you don't want to find the exact value. So yeah, this is the thing. If they ask you to let this equals to this. So another example is they ask you to let fg is gf. So this one is basic function, but now they want to let two composite functions equal to each other. So let's see how that one goes. Same method only actually, just a bit longer only. This one, it could have been direct, but this one needed the quadratic formula thing. So let's say I tell you fg is gf. You have to find this, and we are using back the same values of fx and gx, I mean the functions. Fx is 2x minus 5, gx is x squared minus 6. So from here, how can you get to this assumption. That's the first thing. So you cannot just straight away let this equals this because these are their single functions. They have not been combined yet. So no choice. You have to do it one by one. You have to find first. Wait, I show the thought process here. So first you need to find your FGX. Second, you can find your GFX. Or vice versa. These two are interchangeable. Because finally, your third step is you want to let your FG equals to GF. And from there, number 4 is what is your X value? X equals 1. So this is your flow of ideas. So you must follow the order. Only these two steps you can interchange. So if I want to find FGX will equal to F. So what's your GX? GX is your X squared minus 6. So from here, you're going to substitute your gx into your f function. So x is actually x squared minus 6, just like before. So you will get, let me see. You will get 2 bracket x squared minus 6 minus 5. So I substitute this one into this x part on top here. So you're going to expand this. So by now, this kind of thing solve is considered nothing in advanced because there are much more complex steps. So all this should be at the tip of the finger. So when you learn these expansion things, this is actually lower form maths knowledge. So this one all is actually greatly required in advanced. We don't see it as a great thing because the concepts on top here like this all. This is the part you need to know first. Because if you don't know this part, you won't get this in the first place. So from there on, if you get this, all this is your foundation in maths from your lower form. So you have to expand 2x squared minus 12 minus 5. You will get 2x squared minus 17. So just leave it like this. You don't need to do anything. If you want, you can put number 1 like this. Because you see, right, there's 2 equations involved here. So something like a simultaneous thing. So you can label it as 1 or you can leave it as it is. So from there, you will proceed to GFX. So same thing, G. So your function f is your 2x minus 5. So now here again, so your x now is 2x minus 5. So you're going to put this inside here. So this one, it'll come like this. Make sure square, because here is x squared. Your x only is 2x minus 5. 2x minus 5 is not your x squared. So you need to put square here. And then minus 6 at the back. So from here, this part, you have 2 options. How to solve this? You can expand directly by looking. There is a technique. Or you can do double bracketing. So both is actually correct. There's no right and wrong here. So it depends how you see it. So, but the first method, high risk, because got chance for careless mistakes. Second method, low risk, but more time needed. So, and less time. So you have to weigh which one you want to use to do this. So let's say I choose to put in 2 brackets. Let's say I'm not confident to look at it directly and solve. So you will get 4x squared minus 10x minus 10x plus 25 minus 6. The pattern is like this. So you have to follow the pattern when you expand. So you will get 4x squared minus 20x plus 19. So yeah. So I can label this as number 2. And now when you realize what the question wants, is top part. So yeah, you can write here, let 1 equals to 2. And also, let me see. Yeah, continue writing your FGX here on your left-hand side. Don't forget. so that the examiner knows what is equal to this. Don't just start at the top part and then go on. You make sure that every side you have your labeling as well. So if I say that 1 equals to 2, you will get something like this. Looks complex, but same thing as before. Make sure you get it to your ax squared plus bx plus c format. This is greatly used. You have to know this format for a lot of chapters in NMATS as well. So what I'm going to do is I want to move all this to the right hand side. You will get 2x squared minus 20x plus 36 is 0. So from here, right, you can proceed with your quadratic formula, or you can actually simplify it. So how I get from this to this is I divide the whole equation by 2. This is the step I'm doing. So that I can make my x value just 1 in the front. And it's much easier to use the quadratic formula so that it doesn't get too complex, the number. So after I want to show the method again, it's the same thing. So you will get one of your x values as 7.6458. If you try in your calculator. So most preferably, you leave it in 4 decimal place and 5 significant figures. So I hope you know what is decimal place and significant figures. Decimal place means how many numbers at the back. So you have 4, that's why I say 4 decimal place. 5 significant figure because I have 5 numbers here, 1, 2, 3, 4, 5. So if it's 0 at the start, let's say do I have another x value here? Still greater than 0. Your second x value is 2.3542. So yeah, this is the answer for this equation on top here. So if let's say I got x value like 0.6458, so it still obeys the condition of 4 decimal place, but significant figure is no more 5 at it. Okay? So yeah, that's the thing here. So this part is done. So now we go to a more like something with more variables involved. Actually, it's the same thing again, but here I add on more letters like A and B coming in. You use the technique of comparison to solve this kind of questions. Let you compare your left hand side and right hand side. So let's say I have an equation. I can't see here. Let's say I have fx is ax plus b and f square x is 9x minus 16. So the question is, find the values of a and b. But they provide a condition here. You will find out later why I add this condition, where a is greater than 0. So all these kind of things, right, they tell you in this question, right? It's a good way to check whether your final answer A, are you getting 1 value or 2 values? That's why they give you this thing. So if you are conscious enough, you will know that you are going to expect 2 A values here. So one you have to reject, one you have to accept. Why I say reject and accept? Because they say A must be greater than 0. So if I get a negative number, I'm not going to say that's my answer. So this is the thing why they add here, this condition. So what I'm going to do is f square x is ffx. So this is the thing we learned just now. So f square x, they already gave you the info here. 9x minus 16. So now we have this a and b values are unknown. So f bracket, what is your fx? Whole thing, ax plus b. So I copy back here, I just continue. So now we are going to substitute your x, which is equal to ax plus b, into this x here. So that's the thing happening here. So A bracket AX plus B plus B. So you can see it's getting more complex, but it's the same thing only. It's just I put A and B. That's the only difference. So it's the same expansion here. Just don't be careless because you see so many variables here. So when you expand, you will get A square X plus AB plus B. And you might be thinking from here onwards, what am I going to do from here? How can I proceed to like modify this equation and this? So you have to remember that not everything in an equation is pictured like you can see here on the left hand side. So what they're actually doing here is putting random variables that can give you the same value on your left hand side to solve the question basically. Or else you will get 9x minus 16 is 9x minus 16 done already, what to do? So that's why they create a question like this, find the values of A and B. So what they're going to do here is, I'll write a statement here. By comparing both sides of the equation, so you can see this part, right? It has an x at the end, and here also has an x at the end. So I can say that A square x is 9x, right? Because this part here has more x than this part. So this part we're going to compare with this part. With the x, we compare with the x. So that's how we compare like terms in your lower form maths you have learned. So those are the things. So x and x, you're going to cancel. Because you bring x to this side, you will cancel off with this x. So you get A squared is 9. And now you realize why they give you this condition on top here, where A is 0. If you're lucky enough, if you didn't know, you might write A is 3 and you still get the mark. Because in reality, you can get, when you square root, positive 3 and negative 3. So you're lucky enough, you write A is 3, still okay. You don't need to show the negative 3 because in the end it's rejected. But the knowledge behind it is A square minus 9 when you square root, you will get A is 3 or A is negative 3. So you'll write here rejected. So why you reject it, you can write the conclusion down here. Right on top is better. So you will say, since A is greater than 0, therefore you'll accept the A value of A is 3. So that you address one part of the question already. And then you're going to find your B value. So how you want to find your B value is AB plus B equals to negative 16. So now you know your A value, A is 3 at least. So you can substitute inside. So you will put 3B plus B is negative 16. So you will get 4B is negative 16, B is negative 4. Done. A found, B found. So that's how you address the question. So if you want, you can write a down conclusion down here. A is 3, B is negative 4. So that the examiner knows you have stopped it already there. So yeah, this is how you find it actually. So same concept, nothing so difficult, but yeah, this one a type of question that can also come up. So yeah, this is the thing. So another type is also quite interesting, this one. More challenging than this, of course. So as it progresses, this video, the difficulty level increases, of course. So now you have to master a skill in math. Something very important is expressing relations. Commonly, when you do maths exercises, right, they're going to say express H in terms of K or give a range of answers. So all this comes under the concept of expressing relations. So you need to know how to arrange your terms to fulfill the condition of the question, like h in terms of k, like that. So yeah, so this is a good example of question to show that. So let's say I want you to express find a in terms of b. So let's say I have a function fx is 4x plus a and gx is 2b minus 6x. So we can continue from here. So how you're going to express it? So you have to see here. So what's the question? Okay, so I provide a condition for you here. Fg is gf. So now you don't have to find fg and gf separately. You can do it separately. You have two choices here, 1 and 2. You can first, let's say you want to do things separately, or you can straight away let the fg equals gf and solve from there. So it depends, that's the same thing. So I'm going to choose this method. So how to do it is, you're going to copy back this, let fgx equals gfx. Okay, so from here we're going to proceed. So let's say I want to tackle the left hand side first, fgx. So gx is given here. So I'm going to put it inside f 2b minus 6x equals, now I tackle the right side, g, fx is what? 4x plus a. 4x plus a. So now you are going to apply again the same thing. So substitute this into function f. So you will get 4 2b minus 6x plus a equals to g, not g. Now we're going to substitute 4x plus a into the g function, which is this 2b minus 6x. So x is 4x plus a. So you will copy down 2b minus 6 4x plus a. Looks very complex, a lot of variables involved, but same concept again. So from here, you cannot compare anything yet because there are things to expand first, not like just now. Just now, it's already come out without this bracket things. So now you need to expand. So you will get, wait, here. So you will get 4 times 2, 8b minus 24x plus a equals to 2b minus 24x minus 6a. So you can see a pattern happening here in the question. So what's the question? They ask express a in terms of b, means a equals something, something, something with a b on the right hand side. So from here, how we're going to solve it is, we can cancel off this. Because when you shift this to this side, negative 24 plus 24, you get 0. So I'm going to let a be on the left-hand side. So I'm going to shift this to here. So plus a plus 6a equals to 2b, and shift this here. 2b minus 8b. So you will get 7a is negative 6b. And a equals to negative 6 over 7b. Done. So this is express. This is what I mean by express. You get a on the left-hand side and b on the right-hand side. So let's say suddenly they ask you, I don't want this, I want b in terms of a. How to do suddenly? So you can directly do from here. You don't need to start the whole thing all over again. Copy back this. I can shift the b here. And then I cross multiply. Done. You just inverse the fraction. Here is negative 6 over 7. Here is negative 7 over 6. If you want to shift in. So that's how you do it. So it's the same thing, same concept. Yeah. So yeah, this is the thing of expressing relations. So this is the thing. And then now we are going to using x value. So now we are going to see that what is the value of the composite function when you have, they give you a condition x equals to a number. Let's say x equals 3 or x equals 4 like that. We want to find what is your gfx now. So this part is same concept, but you must know where to substitute. There's two areas where you can substitute this part. So it's up to you again, how you want to do it. So let's say I have functions here. Fx is x minus 2 and gx is 3x squared minus 8x plus 6. So usually the functions they give you here, right, in this chapter, they will involve linear and quadratic only, based on the pattern. I don't think they want to go up till x power 3 because you might need to do expansion with power of p, which is not in the syllabus. Can be done, but it's going to be much longer. So here comes the question. Find the value of GF1. Earlier when I said I will use GFX, but now I put X is 1 year condition here, so this is add-on already. After you learn how to do composite function, they come up with this section. So I'm going to show two methods here. Let's say I divide it with this, which will give you the same answer actually. So let's say we have to find composite function first. GFX is equal to G bracket fx. So your GFX will be G. Fx is what you have to key in the question. So your Fx is x minus 2. So your GFX, you have to substitute your x minus 2 into the function G. Means in all the x areas you have to substitute. So you will get 3 x minus 2 square minus 8 x minus 2 plus 6. So from here, this is where you can choose which method to use. The first method I call sub x equals to 1 directly. Or in this part here, which I'll show later, is you can proceed with simplifying the equation. Okay, so let's say I want to sub directly, see what value I get. GF1. So I substitute x is 1 year, right? So I have to update my equation, put your 1 year in the bracket. So you will get 3, 1 minus 2 square minus 8, 1 minus 2 plus 6. So you see here, all the variables have been cut off a bit. I put with 1, 1, 1 all here. So after you solve, you will get GF1 is 17. Okay, so if let's say you're not convinced with this method, let's say from this part, right, I'll proceed to simplify and then substitute x is 1. So GFX is 3. So now you're going to expand x minus 2. So this part, be careful because you have to times 3 after you expand this. I'm going to put a bracket like this to indicate that I have to times 3 after that. So minus here, you can expand minus 8x plus 16 plus 6. So here now we solve the expansion. X squared minus 2x minus 2x plus 4. Same format, like this, like this, like this, like this. So you make sure you do 4 times, then only you get 4 separate terms. So minus 8x plus 22. So when you expand here again, wait, don't expand yet. Simplify this. X squared minus 4x plus 4 minus 8x plus 22. 3x squared minus 12x plus 12 minus 8x plus 22. You will get this. So now I say when x is 1. So here remember, maintain your gfx all the time so that the examiner knows where you're proceeding. So from here you can write gf1. So if you try to substitute your 1 here, right, you count and see. 3 times 1 square, you get 3, minus 20, plus 34. So negative 17 plus 34, you get 17. Isn't it the same? Wait. Yeah, this is 17. Yeah, correct. Isn't it the same? You see? Two different methods, but give you the same answer. So this is your choice. You can either choose to do this or this. Both also is the same. Only thing this is longer. Of course, all this part here I skip. I direct get the answer here. So yeah, that's the thing here. So if you're going to do to your doubling up function, f square or g square is the same concept. I won't show here or else it will lengthen the video. It's the same thing that we are doing here actually, because it's also a composite function. Okay, so this is the thing here. So now this is another interesting part as well. Now we're going reverse thinking. All the while I ask you to find gfx, fgx, gfx, fgx. So now I want to ask you how you're going to find back your fx and gx. If I give you your gfx or fgx. So now it's reverse thinking time. So let's say I give you the flow chart. So this is what we're doing now. So this is the method we just now used. Now we are going this way. We're going to find this or this. So this is the part we're doing now. So how we are going to do it is, let's say I have fgx is 8x plus 11 and gx is 2x minus 5. So now they ask you to find fx. How are you going to do it? So let's see. So you cannot start anything with gx, of course, because it's a simplified one, but you can always start complex and go simple. So fgx is equal to 8x plus 11. Don't forget, you can express this because it's in the form of variables. So f, here you can have 2x minus 5 equals 8x plus 11. And don't do the silly mistake. Since you think here is times and you get the answer fx is 8x plus 11 over 2x minus 5, wrong. Big wrong. It's not how we do it. So there is a reason behind this. Because here we don't have an x term, remember, this is just a function f. So this is not representing your fx, fully speaking. So how to do it is, I love this. So you will have f, what's your gx? 2x minus 5 equals 8x plus 11. Same composite function thing. So from here, we are going to do a step. This also represents y, if you notice. Y is gx. We're going to use this step here. So I'll say let y equals 2x minus 5. You want to find fx, right? This is our question. So why don't I express this equation, express x in terms of y, so that I will already have fx. So this is what I'm thinking here. There's also two methods here. You can also, no, it's not only one method. You have to do like this. So you will get 2x minus 5 is y. 2x is y plus 5. X is y plus 5 over 2. And if you realize here, you have an x term. And you can substitute this one here, inside here. So what you will get is fy. Don't put fx here, because you said let y is 2x minus 5. It means this part you're going to replace with y first. Then only you change to x. It's the same thing. So you will get 8 y plus 5 over 2 plus 11. So you simplify, you will get 4y plus 20 plus 11, which is 4y plus 31. So now you can say substitute y with x to address the question, because they didn't ask you fy, they asked what is fx. So you will get fx equals 4x plus 31. Done. So that's how you find your function back from the composite function. And then now it's also an interesting part that I'll show you. Let me leave this part here. Okay. I show you simultaneously on top here. Okay. Okay, so this is checking time. Let's say you not confident of the method you use, or you made careless mistakes along the way. This one method I found. So let's say you want to know whether this answer is correct or not. You put back this answer and find back your FGX. Reverse again to the normal method that we use. So you're going to do back the composite function. So you want to find FGX now. So you want to see whether you get 8x plus 11 or not. So FGX is the given the question, 2x minus 5. And I will put what's given the question here, 8x plus 11 on the left hand side equals to now R. So based on your answer here, you can test. Let's say your fx you got here is 4x plus 31. So I'm going to put my 2x minus 5 into the x here. So you will get 4 2x minus 5 plus 31. So we keep on solve, you'll see that minus 20 plus 31. When you get like this, what does it mean? Means it's proven, no? Your left hand side is equal to your right hand side. Means this answer here, 4x plus 31 that you got here is verified to be correct. So this is how I check that the answer here I got is valid or not. So it's kind of like a trick you can use to know the answer indirectly. So yeah, that's how you do it. So you can do it separately like this as well. Okay, so this one part. And there's another possibility of question they can come out from here as well. So let's say I have a function like this. Oh my. Fx, I'm using the same example. This time I'm going to give you that I want to find my gx instead of fx. What is my gx now? So that's the two possibilities of questions they can ask here. So let's say now I'm going to find back the same thing. Fgx is equal to f bracket gx. This time I cannot fill in anything here. Just now I could fill in a value here because I knew my gx. Now gx becomes my question. I twist the question upside down. So fgx, you have here 8x plus 11. So now what you're going to do is, may look complex, how to proceed here. So gx now in turn will become your x, which you will substitute on top here into the x of the fx function. So this is how it works. So this whole thing becomes your x. So you will get 4 gx plus 31. So you expand, you will get 4gx plus 31. You want to find gx. Remember, these two is bonded by times. So later you can shift over to divide. So you will get 4gx equals 8x. So I see the 31 here means minus 31, you get 20. So you will get gx is 8x minus 20 over 4. And I can simplify. 2x minus 5. Done. Then, just now I had the same question and I got 2x minus 5, so it's the same answer. So this is how it's solved for gx, if they twist the question for you. So yeah. And then, if you want to know whether your answer is correct, you do the same thing like before, check answer with that method. So follow that method for anything. So that's for your check answer part. Okay. So yeah, that's the basic knowledge of functions all covered already. So now we are actually going to something quite unique as well, which is you want to derive pattern from functions, from a composite function. Since we already learned composite functions, so we're going to apply this knowledge to create a general formula that can represent all possible values of x. As I mentioned very the beginning, the n term. So this is what I'm talking about here. So let's say I have a function fx is 1 over x squared. Okay, reciprocal function, something like that. And now they're going to ask you find f square x, f cube x, f4x, and then they say, and hence determine the general formula, to find out f power 22x and f power 33x. So don't get scared when you see such numbers like this. Don't tell me you're going to do it 22 times, right? You can't solve 22 times of this and it'll take forever. So you have to see patterns. That is why we have patterns in maths, to derive a conclusion to induction to creating such general formulas. So that's how we can deduce something that is bigger than the normal function that we want to find based on patterns. We observe how it changes with certain numbers that we use. So if I want to now they ask you this part, concentrate on this part. Find f square x, f cube x, and f4x. So they want to use this, and always take note of this keyword hence. Whenever they say hence, right, means this answer that you will get from this question actually depends on these answers on top here. So you have to correlate with the first part of the question and the second part. So let's say I want to find f square x. So you'll do the same thing, fx. So your fx is 1 over x squared. And you will substitute the x as 1 over x squared. So now it's getting bigger. You can see a pattern coming. So you'll get 1 over x squared. So don't get confused here. You just expand the bottom as it is, 1 over x power 4. So when you have 1 over x power 4, so means what's happening here is you do 1 times x power 4 over 1. So that's how it works. Or in simple words, they say throw your x power 4 to the top. So directly you can see that it's x power 4. This is what is happening behind it. You reciprocal the denominator. So now I get already that this is your f squared. So yeah. And then we proceed f cube x. And now you might be thinking, am I going to do f function 3 times? You can, but it's going to waste a lot of time. So how you want to do this is, do you notice that f cube x can be formed to a combination of f and f squared x? Since you have the answer of f squared x over here, you can direct sub here. And why I say is this, because remember your indices. F power 1 times f power 2, you get f power 3. So this is the concept here that I allow to use like this. So you can sub f squared x, x power 4, and you substitute into the original function here. So you'll get 1 over x power 4 squared, this whole thing squared. So you will in turn get 1 over x power 8. This is your answer for f cube x. So later on you can write in the form like this because we want it consistent, right? We want only x power something. So you can change to x power negative 8 or x 2 power of negative negative 2 power of 3. So that we get the same base. Here so I can write as x2 power 2. So that you can observe a pattern that will be recurring later with this 2 power n. This is your n value on top here. You see it's changing 2 and 3 now. So from here, you will continue solving the part of the question. This part done with the other. So they ask you to find f power 4x. How are you going to do that? You can do f square x, or a simpler option, you just maintain the f function with power 1 in front, so that is easier, and then you bracket f cube x. Because f cube times f power 1, you get f power 4. So f cube x is, I will use this much easier. 1 over x power 8. Same thing again. You will substitute x as 1 over x power 8 inside here. And then you square the whole thing. So you will get x power 16 down here. So you will in turn get x power 16. So can you notice a pattern that's happening here? Whenever I have an even number of a function like f square or f4, I get x with a positive power. But if it's an odd number of function like f power 3, I will get an x with a negative exponent. So that's a pattern recurring here. And that's how I solve this, I solve this, I solve this. And I say hence determine the general formula. So how you write it out actually. So the general formula will be x squared. So x squared. So now I have two conditions. If n is even, the n term is the top part here. 3, 2. Here I will get x is 2 power 4 to get 16. So if n is an even number, so you will get a general formula of x 2 power n. If n, this is your fnx. This one I'm telling you. So the n term is actually on the order of the function. How many times you do the function? And if n is an odd number, you will get x negative 2 power n. See, a negative is added here, as you can see here. That's why they ask you to find 3 times. Because from one number alone or 2 numbers alone, you can't derive a pattern in math. You need repeated examples up to a certain point that you're sure that this is a pattern that's happening. So yeah. So now they ask you to find f squared, f22x and f33x. Do you need to do 22 times like this? No need. Because you have the general formula here. And you just substitute n is 22, n is 33 into the function. So let's say n is 22, means n 22 even number, right? Because n with 2. So x2 power 22. So no need to find the value. That's based on your calculator. You just stop here. This is your answer. And if n is 33, you'll get x negative 2 power 33. You don't need to find the value actually. Just stop here is enough for this. So yeah, that's the answer. So you can do like that. And yeah, we are already coming to an end already. So second last part of this subtopic. And also one thing to note, remember your simultaneous equations concept because it can be tested in this chapter as I showed you before as well, like your comparing left hand side and right hand side, that comes from your simultaneous equation thing. So another popular example to take note, they like to draw this diagram in the exam. And it also came in SPM past year. So how it looks like is very typical. They'll give you three circles like this. And they will say P, Q, R. So now they will draw arrows that map these three things like this, and like this. So P to R is like a shortcut. If you want to go you want to use Q, you will go P, Q, Q, R. So it's like using two ways to cover one way. So they lead you to the same destination. But this is how they use composite functions to show you the end result. Okay, so let's say I say that P to Q is x minus 2. And here I say g f x, the function is x squared plus 4x minus 4. So they say it's given that set P maps to set Q by the function I'll write as fx to fasten things up, so that is easier. X minus 2. So they ask you to write the function notation that maps set P to set Q. So as I told just now, you must know how to properly write function notation, not just the value x minus 2. So that's why they give you this info here. So gfx, it recalls your previous knowledge, means you're doing f function first, followed by g function. So you see, f function is mapped first, then followed from q to r by the g function. So this is what's happening here behind this diagram. P to q, f, and q to r is g. So this is how it will look like, this is the answer. Fx will map to x minus 2. Yeah? F, so this is like your x, P is your x, Q is your fx, and it's mapped by x minus 2. So yeah, this is the answer. And then they ask you to find the function, the second part. Find function mapping set Q to set R. So now we are going to find the same knowledge as before actually. So you have your fx is x minus 2, which is shown by set P to set Q. And you have the info of the question, gfx is x squared plus 4x minus 4, set P to set R. So the missing info now they ask you to find is gx, which is mapping set Q to set R. So I won't show the method again. It's the same thing like we did before. So you have to apply the same knowledge. And then you solve, you will get gx is something. And then you can check the answer with the method I told like before. So now this is the last part already. And definitely the hardest part of this topic now. So everything that we learn now, we are going to turn it to daily life situation. So that's why they always end the chapter with daily life examples. So daily life equation to show composite functions. So how they do these questions are they will take maybe two or more quantities and create a situation that can ask you to generate equations for the specific relation between two quantities, and then you find the overall relation, which is the composite function. So this is how they are playing with the question. So let's say I create the situation here. Situation I give is production of goods per day by the factory. And how to make this question to a composite function is I add another info, which is the cost to pay for each worker. So you see there's many variables going on, production of goods per day and the cost, and also the number of workers. So this is how they create a composite function question. So you know composite functions, you have to use letters. So we are going to let all these quantities equal to a variable. So let number of goods is P. I think this you have to show, you have to write down so that the examiner knows where you're going, or they will tell in the question. Number of workers is N. So let's say I have the function of, I'm going to relate these two. How many workers can produce how many goods? So Pn. So N becomes your object because from worker only you can get goods. The goods don't come without the worker. So that's why worker is the object in this situation. So Pn is 20n minus half n squared. Let's say I create this function for you. And then the total revenue. This one we are talking per day. So don't get confused with day, month, and week. So let's say I say it's R, and in the unit of Rm. So Rp is equal to 40p. So why I relate R and P here? Revenue and goods. Because from goods only you can get the revenue. You don't get the revenue without the goods. So that's why your goods becomes your object and revenue is your result, which is the image. So this is how it works. So now the question comes. Find the total revenue. So they're still sticking to 1 day. So you don't have to times 12 for 1 year. If number of worker, they have to give you this, or else you won't get a value. And it's 20. So total revenue underline means your final answer should get in RM. So you're going to do composite here. Same thing again. It's just they create a situation for you only. So you shouldn't be scared because of this situation. So RPN, we're going to combine these functions. So why I say RPN, you can see the overlap here. So you have to do the relation between worker and goods first, then only you can find the revenue. So the flow is something like this. Worker to goods to revenue. This is your thought process. Because worker produce the goods give you the revenue. So this is the flow chart that comes. So that's why I say RPN. P is this one, N is this one, based on all this. No? So this is R, sorry. This is R. So you're going to do function P first, then followed by function R. Number 1, number 2. So now we solve the R. Pn was the function given this. 20n minus half n squared. And you're going to substitute this into your RP. This comes your P. So you will get 40 bracket 20n minus half n squared. So you times by 40 basically. So you will get 800n minus 20n squared. So this is your RPM. And now refer back to the question. They ask total revenue. So total revenue is shown by RPM if number of worker N is 20. So now you can substitute the D. Or you can say like this. When N equals 20, RP20 equals 820 minus 20 bracket 20 squared. So you'll get RM 8,000, quite a lot for 1 day for all the workers. So that's your answer, RM 8,000. And then let's say I want to check back whether I substitute correctly or not. You can do one method here. I'll leave this part here. This is the function I got. This is checking only whether N is 20 or not. So you got the answer here. So you can say let 8,000 is 800n minus 20n squared. This is the result of your composite function of 800n minus 20 n square. So again, it's a quadratic. So you will get negative 20 n square plus 800n minus 8000 is 0. So I make it positive. So then I factorize, I will get 40n plus 400 is 0. So this you can use simple factorization, only the quadratic formula. So n. So what combination can give you negative 40n, 20 and 20? And you want negative 40n, so both sides should be negative, because negative and negative you get positive 400. So in conclusion, n is 20. And you see it makes sense with the question here, n is 20. So it's proven already. So yeah, remember. And also daily life situation, do not forget your 3D shapes formula, because they can relate quantities involving 3D shapes like area, radius, perimeter, and so on, and volume. So this is how they can create composite function questions as well from physical quantities. So yeah, this is one thing to take note as well. So yeah, I think that's all for this video today. And I hope that you learn something more deeper about composite functions and can understand how to do composite functions better. So yeah, so next topic will be inverse functions, which I'll do later on. So hope you like the video and continue to show your love for this video. Thank you.